Hey guys, take out the supplemental practice that you got yesterday in class, and we're going to go through a selection of them for 15 minutes. So however many I can get through in 15 minutes of video. If you didn't get one yesterday, if you were absent, I put a few on the front of my desk. So we're going to start with some evens. In particular, we're going to look at number 2 because number 2 can be tricky. Remember what we do when we have this negative exponent. We take whatever's in the parentheses, which in this case is a -8, and we flip it. So we go 1 over -8. And then we raise it to the positive 2/3. So that's the first step you would do for that one. Then you have two options. You can go to your calculator and do the original one. Make sure you enter the parenthesis, the negative, the 8, the to the -2 divided by 3. Or if you want to use this one, just go 1 over, because 1 is a 1, and just do -8 to the positive 2/3. All right, so I'm going to leave this empty just to make sure you have a calculator out and you're working your calculator. So you would need to do -8 to the 2/3 power. Remember to hit math, enter, enter if you have a decimal. This kind seems to have been messing with our heads all chapter, so we'll do number 4 next. Before we can work with the exponents, we need to see them. So remember, this is actually a 1 and a 1 on that 5 if you can't see it. Remember, if you don't see the index, there's actually a 2 there. And so this would be 7 to the 1/2. Right here, this is 5 to the 1/3. The bottom is the root. This would be over 5 to the 1/6. When you divide, you subtract the exponent. So we'll do 5 to the 1/3 minus 1/6. And again, if you're uncomfortable with the fraction part of it, just go ahead and use your calculator to do 1/3 minus 1/6 and then hit math, enter, enter to supply this fraction. And again, I'm going to leave some stuff off just to make sure you're not just copying stuff down. So you'll have to go to your calculator and wrap that up. And I do some of them in full, but not that one. Number 8. There's 8. Let's do 6. Let's stick with the evens. They seem to be going just fine for me. So when I have an exponent outside of a chunk of parentheses, what I do is I go raise everything in it to the 1/3 power. So I would do 8 to the 1/3. Then I would do x to the 7th to the 1/3. And when we do that, actually I'm going to cancel that. I see that I can do some cleanup inside of those parentheses first. So before I deal with those x's, I think I'm going to cancel one of them on the bottom. We'll cancel one of them on the top. Similarly, I have 2 y's on the top. They're going to cancel out 2 on the bottom, leaving a y to the 9th. So I'm going to do a little rewrite on that before I start. I actually have 8x to the 6th over 27 y to the 9th. That's what I do. I'd clean up in there before you start dumping that 1/3 power in. So I have 8 to the 1/3. You can do that on your calculator or in your head, but you just go 8 to the 1/3 power if you want on your calculator, or we've had that one so many times you should know that it's a 2. X to the 6th to the 1/3 power. Remember, we multiply those. We do 6 times 1/3. On the bottom, we do 27 to the 1/3 power, which is the cubed root of 27, or do it on your calculator, but that's a nice 3. And again, if you do it on your calculator, you do 27, caret key, 1 divided by 3. And then y to the 9th to the 3rd, we multiply those exponents. 9 times 1/3 is 3, so we'd have y cubed. We'd lock and load it, and we'd be done with that one as well. Next even one that we'll do, number 8. So if I had a negative exponent, I'd deal with that first. I'd flip everything and go positive probably, but not necessary in this one. Sorry, I had to take a drink of water and then I choked on it. I'm alive, no worries. All right, so I'll do negative 27 to the 2/3 power, and I'll do x to the negative 9th to the 2/3 power. This can get done on my calculator. Make sure you put it in parentheses, so I'll let you guys do that. You'll go parenthesis, negative 27, close it, to the, and then you'll do 2 divided by 3. Make sure you hit math, enter, enter, and write it down. Again, I'm not going to do everything, so have that calculator out. That would go right here. I don't even have a calculator on me, so on the next one, when I distribute these powers in, I multiply them. So I do negative 9 times 2/3, which would give you a negative 6. The problem with that is I can't leave negative exponents. So I'd have to take that negative 6 and put it on the bottom as x to the 6th. And on the top would be whatever you got when you did negative 27 to the 2/3 power. Moving right along. The next section for the solving section, remember your job is to get rid of what's in the way by doing the opposite. So you're on the x attack. We attack it from what's farthest away first, or what we used to say you isolate the root stuff or the power. So I need to get that by itself. I need to get this by itself. To do that, on this one, first thing I do is add 7. And I'd say 2x plus 3 to the 1/2 power equals a positive 7. Next thing I need to do is get rid of the 1/2. Remember what we said, we raise both sides to the reciprocal or flipped power. The reciprocal of 1/2 is 2 over 1, or just 2. Whatever I do on the left, I have to also do on the right. This undoes each other because I get 2 over 2, which is just 1. So it pops off that exponent. So I get 2x plus 3 is equal to 7 times 7, which is 49. And then you guys know how to solve that on the rest of the way. So let's go look at number 12. Number 12, the root is isolated, but my x is trapped under it. So the first thing I need to do is pop that square root off. The opposite of square rooting is squaring. It'll pop the root off over on the left, and on the right, you're going to need to FOIL. So we'll do on the right, we'll do our first, outsides, insides, and lasts. So I do my firsts. My outsides are 4x. My insides are 4x. That gives me 8 x's. My lasts is 4 times 4, which is 16. Whenever you have what's called a quadratic equation, which means you have a second degree, you have to solve them differently than the one like up here where you just say, oh, I'll subtract the x by subtracting 3 and then dividing by 2. You need to get one side equal to 0 to solve your quadratic equation. So we're going to get that x off. And at the same time, we might as well get that 6 off so we don't have to do a double rewrite. So my new quadratic equation would be 0 equals x squared. I'd have plus 7x, and then I'd have a plus 10. Remember, to solve this kind, I need to factor them. So I need to figure out what multiplies to equal 10 that I can get a 7 out of. And we'll use 5 and 2. Obviously, they can both be positive. So I'll say x plus 5, I'm running out of real estate here, times x plus 2 is what has to equal 0. So now I'm going to get two answers out of here. I'm going to get a negative 5 is what makes this piece 0, and a negative 2 is what makes that piece 0. Before I circle them, though, this is the type where you had to go check. Whenever you do that foiling, kind of put that in your head. When you take your test, if you foil one of the sides, you're going to need to go check and make sure your answers work. So let's go take a look. When I put in a negative 5, add 6 to it, I'll have the square root of 1. On this side, I'd get negative 5 plus 4, which is a negative 1. The square root of 1 is not negative 1. Square root of 1 is 1. So the 5 is out. And let me show you the negative 2 working just so you can see it. A negative 2 plus 6 is 4. So I get the square root of 4. A negative 2 plus 4 is 2. This is true. So this guy right here is my answer. The last one of this type, number 14, again, I'm on the attack of x. I need to isolate the chunk first. So I need to get this by itself, which this means I need to divide by 4. On the left, when I divide by 4, it'll be gone. On the right, when I divide by 4, 36 divided by 4 is a nice 9. Now that I've isolated that chunk, I need to get rid of the exponent. So I raise both sides to the reciprocal power, or the flipped power. So to the 3 over 2 and to the 3 over 2. Remember why we do that. We end up getting 6 over 6, which is 1. Anything to the first power is just itself, so it's completely gone. And I get 3x minus 3 is equal to. If you don't know what this is, remember when it's numerical, you can go to your calculator. It really means it's the square root, because the bottom is the root, of 9 cubed. But your calculator, if you do 9 to the 3 divided by 2, and again, math, enter, enter, it'll tell you that that's a 27. And then you'll solve the two-step equations. You'll have to finish that one on your own. I really wanted to get to the graphing because these were the ones you guys struggled with. So I'm going to go real slow. This is probably all the farther I'll get today with these. So for the graphing, remember you have square roots and cubed roots. The process is the same, but the parent function, the one you start with, is different. So the parent function for the square root graph, the numbers you choose are the square root of 0 is 0. The square root of 1 is 1. And then remember, we don't choose 2 or 3 because those are ugly. We say the square root of 4 is 2. The square root of 9 is 3. So we choose those first 4 numbers. That is the parent function. Then what we do is we multiply it by whatever's out front. If there's nothing out front, we just go graph it. But this says I have to take the opposite. The y's are opposite. So I'm going to deal with flipping it on my chart, not on my table. So the opposite of 0 is 0. The opposite of 1 is negative 1. And again, if that was a 3, I'd multiply everything through by a negative 3. So I'm flipping it on the chart. And then we cross that off. So anything out front, multiply by it before you graph it. If there hadn't been anything out front, which is going to happen over here, then I don't need to multiply. Just go plot the parent function. So 0, 0 is on my graph. 1, negative 1. 4, negative 2, and 9, negative 3. And it looks like this. That's not my answer. I'll do my answer in red. I took care of the parent function and I flipped it, but I still have to put what that minus 4 does. If it was outside of the root, it would move it 4 down. But remember, when it's in the root, it moves it 4 to the right. So I'm going to take every point and move it 4 to the right. This one's going to go 1, 2, 3, 4. This guy's going to go 1, 2, 3, 4. And this guy's going to go 1, 2, 3, 4 and end up over here. I'll regraph it. This is my answer. So when you do the square root functions, you always get, I usually call them the shout out functions. They look like that. But when there's a negative in front, you'll notice it flipped it over, and then that minus 4 moved it 4 to the right. If this had had a plus 2 on it, then I'd take all those and also move them up 2. So that's done. The domain of this is what x can be, and it can't be all reals. My x's don't start until I'm at this big dot. This is where the x's start, and they're all that way. So my domain would be x has to be greater than or equal to 4. It's whatever makes what's under that root 0 right there. My range is what the y's can be, and you'll notice that my y's, again, are always below that. My y's are less than or equal to 0. Then it says describe the transformation. So I have to say, what did this do? We had an x-axis reflection, and then we moved 4 to the right. So again, the square root graphs, and you will have one on your test. Maybe it'll be the square root of x plus 1 minus 7. You're going to do the parent function, which is always 0, 0, 1, 1, 4, 2, 9, 3. Then you'll double everything. You'll go graph it, and you'll move everything 1 to the left and 7 down, and you'll have your new parent. The cubic function's a little different because it has a different table that I make. For the cubic function, remember we do -1, -8, 1, and 8. That kind of needs to be memorized. The cubed root of 0 is 0. The cubed root of -1 is -1. Cubed root of -8 is -2. And then this is 1 and this is 2. So it always goes -8, -1, 0, 1, 2. You're going to need to memorize it. Then, if there was something out front here, which there isn't, but if there was, I would apply that, cross this row off. But again, if there's a 2 right here, I'd make this a -4, and then a -2, 0, and then I cross that middle one off. But because there's no stretch for this one, and I don't need to stretch it, all I simply do is go graph these points. I go -8, -2, I do -1, -1, 0, 0, 1, 1, and 8, 2. So it comes like this, does a little deal in the middle there, and goes like that. That's the cubed root. But that's just the parent function. Now I have to do the transformations. I need to move every point 2 to the right and 5 up. So I'm going to grab every point and go 2 to the right, 1, 2, 1, 2, 3, 4, 5, up. Then I'm going to go 1, 2, 1, 2, 3, 4, 5, up. I like to do this one more bold once I graph it, but it's going to go 2 to the right, 1, 2, 3, 4, 5, up. I like to know that's where I start to turn. Where was I? This next one goes 2 to the right, and 1, 2, 3, 4, 5, up. And then this one 2 to the right, 1, 2, 3, 4, 5, up. I start over here with arrows, I come in, I turn at that big dot, and I head on out. This is my answer. For the cubic, domain and range is really easy because it's all reals for the domain. X isn't bound on the left or the right. And the range is also all reals, not bound on the left or the right. Those are worth practicing because they're worth a lot of points. But that's it for the day. Tomorrow you'll take a practice test for me. You'll be with me all day tomorrow, so we won't work anymore on this supplemental packet. That's on you. You guys have a good one.